Gemma and Phi are the two models in this series that argue small is enough for serious work. Gemma makes that case through Google DeepMind's research depth and a layered safety architecture. Phi makes it through synthetic training data and benchmark scores, a model that runs on a laptop and beats larger models on reasoning tasks. Both arguments are real. Both fail in a specific way. Gemma's failure is what it says. November 2025. Gemma falsely accused Senator Marsha Blackburn of a criminal act. Google pulled it from AI Studio. The model with the most safety tooling in the series produced a defamatory hallucination about a named public official. Phi's failure is what it claims. January 2025. Phi models are known and proven to be overfitted to benchmarks. February 2025. 10 to 20% score loss on unseen but similar tasks. Two small model cases, two different ways of not quite delivering on the promise. Google DeepMind entered the open-weight AI market in February 2024, with Gemma 1, 2 billion and 7 billion parameter models built on the same research lineage as Gemini. The context was competitive. Llama 2 had launched in July 2023. Mistral had dropped the torrent in September 2023. Google's developer relationships were at risk without an open-weight answer, and the open-weight community was building without Google's participation. Gemma 2 followed in June 2024 with 9 billion and 27 billion parameter models. Gemma 3 in March 2025, 4 sizes from 1 billion to 27 billion, a 128,000 token context window, 140 plus languages, running on a single GPU. Gemma 4 in April 2026 under Apache 2.0. Microsoft Research arrived at the small model Thesis through a different route. Sebastian Bubeck and his team published Phi 1 in June 2023, alongside a paper, "Textbooks are all you need." The argument was about training data quality, not architecture scale. Synthetic textbook examples, structured exercises, a 1.3 billion parameter code model that outperformed much larger competitors. Phi 2 followed in December 2023 at 2.7 billion parameters. Phi 3 in April 2024, a product family small enough to run on a phone. Phi 4 in December 2024 at 14 billion parameters, with a reasoning focus and synthetic data dominant. Both teams arrived at the same destination through opposing starting points. Google applied frontier research infrastructure to small models, the same architecture principles and training approach as Gemini, distilled into sizes practical enough to run locally. Microsoft applied data quality theory. If training data is the constraint rather than parameter count, synthetic textbooks and curated exercises can produce competitive capability without frontier infrastructure. Failure modes of these two models are structurally opposite, and that is what makes the comparison useful. Gemma's documented failures are about what the model outputs. The Senator Blackburn incident is the most specific, a named defamatory hallucination about a public official, severe enough that Google removed the model from its own platform without delay. The September 2025 ARC review paper confirmed that hallucination rates in the Gemma 2 family are structural, not size-dependent. The problem persists as models scale. Gemma 4's first week in April 2026 added deployment failures in unsloth and llama.cpp, temporal confusion, and silent reasoning stops. The safety architecture designed to prevent harmful outputs did not prevent a defamatory one. Phi's documented failures are about what the model claims. The community's benchmark contamination concern is not a single incident. It is a sustained, documented position held across multiple threads over more than a year. Phi models are optimized for the benchmarks used to evaluate them, and performance on similar but unseen tasks drops by 10 to 20%. May 2025, hallucination and looping on Phi 4 Reasoning Plus. August 2025, Mount Sinai researchers place Phi 4 in the high hallucination tier in a medical evaluation. February 2026, excessive token usage and frequent refusals on non-STEM topics in real tests. One model is questioned for what it says about real people. The other is questioned for whether what it says about itself is accurate. These are not the same reliability problem, and the difference matters for how each model should be deployed and what verification steps should come before committing to either. for a production workload where the cost of a wrong answer is high. The practical comparison between Gemma and Phi at the small end is the most direct size-for-size comparison in the series. Gemma 3's 12 billion parameter model with a 128,000 token context window versus Phi 4 Mini at 3.8 billion parameters with a 16,000 token context window. Gemma wins on context by a factor of 8. Phi wins on footprint. For long document work, multilingual applications, and tasks where context length is the constraint, Gemma's 128,000 token context at compact sizes has no equivalent in the Phi family. Phi 4 at 14 billion parameters offers 16,000 tokens, and smaller Phi models offer less. The context window gap is 8-to-1 in Gemma's favor. For edge deployment on the smallest hardware, structured reasoning, and mathematics, Phi 4 Mini at 3.8 billion parameters is the smallest model in this series with a credible reasoning capability claim. Gemma's 1 billion parameter model competes at the absolute edge tier but is more limited on structured reasoning. On the language question, Gemma 3's 140+ language support makes it the only model in this series with a credible multilingual deployment case at small sizes. Phi has no comparable language coverage at any size in the current family. The over-refusal problem is shared, and that is the most unexpected point of similarity between two models that are otherwise quite different. Gemma 4's default behavior required users to apply obliteration in the first week of its release. Phi 3 required the Kappa 3 community fork to remove refusal vectors before the model was practically useful for ordinary requests. Both models have safety training aggressive enough that their communities have built tools to work around it, rather than accept the defaults. Gemma is the correct choice over Phi when the requirement is long context work, multilingual deployment, or vision tasks at small sizes. The 128,000 token context window at sizes that run on a single GPU is Gemma's specific position in this series and one that Phi cannot match at any current model size. For researchers who want Google DeepMind's research backing and structured safety documentation, Gemma is the more developed platform. Phi is the correct choice over Gemma when the requirement is the smallest possible footprint for a structured reasoning task on edge hardware, or when the workload is mathematics, code, or structured question answering at sizes where even Gemma's most compact competitive models require more resources than the deployment allows. Phi 4 Mini at 3.8 billion parameters is the most portable serious reasoning model in this series. For teams in the Microsoft Azure ecosystem, Phi's integration is the practical argument. The license comparison has shifted with Gemma 4 and the current Phi generation. Gemma 4 under Apache 2.0, Phi 4 Mini under the MIT license. For earlier Gemma models, the terms carried an updatable, acceptable use policy that made long-term deployment commitments uncertain. For the current generation of both models, the license is no longer the differentiating concern it was through most of 2024 and 2025. The small model case for open-weight AI in 2026 comes down to which failure mode is more acceptable for the specific workload. Gemma's failure is in what it says about named people, a hallucination specific and confident enough to require a platform removal by Google from its own product. Phi's failure is in what its benchmarks claim about its own capability, scores that the community has documented as measuring training distribution performance rather than general reasoning. Neither is the safer choice in every context. The question is, which specific risk is more acceptable for what is actually being built?